Hello and welcome to the video for the first sample problem from section 16.2. We'll have a second one also. So you can see that both of these are calorimetry type problems. We learned about calorimeters and how we can use calorimeters to figure out, well, things like, how many calories there are in in some food, or something having to do with, how much energy is lost by a substance, or even, things like temperature changes and masses, and we'll see those in these sample problems. All right, so let's take a look at this one here first. This one, if you read the question right here, and I am circling this right here. Let's see, I'll put a little rectangle around the question here. It says a serving of pizza is placed in a calorimeter. The pizza is encased within a waterproof box and immersed in 2,000 grams of water, 2 kilograms of water. When the piece of pizza completely ignited, the water in the calorimeter rose 17.5 degrees Celsius. How many kilocalories are in the pizza? And we're told that the specific heat capacity of water is 4.184 joules per gram degrees Celsius. Okay, so we're trying to figure out, well, how many calories are there in pizza? Now we're actually trying to figure out how many kilocalories, which is, the calories with the capital C that they put on packaging. Okay, so let's take a look at how we're going to do this. What is our plan? Okay, we're going to say that in this calorimeter, maybe I should do a drawing here, and oops. I should get my pen back here. First off, let's undo that. Get my pen back here. So we have this calorimeter, this container right there, and inside this container is filled with water. We got 2,000 grams of water, and in some box right here, we have a piece of pizza. So there's your slice of pizza. I'm going to figure out how much. Probably put some pepperonis on there. Right. So we're trying to figure out how many calories are in this slice of pizza. So we're going to ignite it. And when we ignite this thing, then all this heat starts going out. Okay. And so when that happens, the water here gets warmer. So we can say that the Q of the pizza, we can think of the pizza as a system, is equal to the negative Q of where this is going, which is basically of the water. Okay, so let me get rid of that. So this right here, the Q of the pizza, will be our calories, or our energy inside the pizza. And what we're going to do is we're going to figure out how much Q water had, and whatever the Q of the water, that's going to, the negative sign is going to be that of the Q of the pizza. So we need, basically what we need is the Q of the water. And the Q of the water is equal to the mass of the water times the specific heat capacity of the water times the delta T of the water. Okay, and if you look at the problem, you're given basically all these things here. We're told that we have 2,000 grams of water. That's the mass of the water. Specific heat capacity of the water, C of H2O, is 4.184 joules per gram degree Celsius. Remember, the units for specific heat capacities are joules per gram degree Celsius, because they're telling you how many joules it takes to take 1 gram of the substance and raise it 1 degree Celsius. And then it tells us our delta T. We don't have to calculate it out. It already says the water temperature rose 17.5 degrees Celsius. So 17.5 degrees Celsius. All right, so let's put all that together. And what we have is the number 2,000. So let's use our calculator. 2,000 times 4.184 times 17.5. That is 146,440. 146,000. 146,440. Let me double check that 2,000. Okay. Now you'll notice that the answer here, the units for the answer, is going to be joules, because your grams and your mass cancel with the grams in the specific heat capacities units. Degrees Celsius also cancel, in the delta T cancel with the degrees Celsius in the specific heat capacity, leaving you with just joules. All right, so you just have joules. Now, we were asked for kilocalories, not joules. So we do have an answer, but it's not in the right units. Okay. So what we're going to do here is we're going to go ahead and move this up just a little bit so we can go ahead and convert from joules to kilocalories, or thousands of calories. So let's go ahead and do that. Let me go ahead. So this number comes out right. So we got 146,440 joules. Then we want to convert it. If you look up the relationship between joules and calories, there is 4.184 joules in 1 calorie. So since they equal each other, we want joules to cancel. We put the 4.184 joules on the bottom. We're going to be left with calories on top. The joules here cancel. And if we take 146,440 divided by 4.184, that's going to give us 35,000. That's going to equal to 35,000 calories. Okay, so those are calories, and we want to convert them to kilocalories. So 35,000 calories. Remember that a kilo is 1,000, and so a kilocalorie is equal to 1,000 calories. 1 kilocalorie is equal to 1,000 calories. So I take 35,000 divided by 1,000, that's going to be just be 35.0 kilocalories. We call it kcals or kilocalories. And there is your answer to that problem. Okay, sounds like a pretty skimpy piece of pizza, because I think I messed up on one of the digits somewhere, but it'll work. That's kind of the way you do it. So one more time, just go ahead and review here real quick. The whole idea was the Q of the pizza, the heat that came out of the pizza, and that's how much energy was in it, is going to be turned into the water. So Q of pizza is equal to minus Q of the water. Here we have a system, here we have your surroundings. Putting the two together, that's your calorimeters, our universe. So if we figured out the Q of the water, that would be the Q of the pizza. So H2O, Q of the water is the mass of the H2O times the specific heat capacity of the water. I think my pointer is showing up over there, so I'm going to go ahead and do this. We figured out the Q of the H2O because we had the mass of the water, the specific heat capacity of the water, and the change in temperature of the water. Plug those in. Right, here's the mass of the water. Here's the specific heat capacity of the water, the temperature change of the water. That gave us 146,400. That was our joules. And because we were asked for kilocalories, we needed to go ahead and convert the joules that were given over here into calories. Using the relationship 1 calorie is equal to 4.184 joules, we have to look that up. It's always there. And then once we had the calories, we converted into kilocalories, because we know whenever there's a kilo, it means 1,000 of these guys. Right? So 1,000 calories, and that got us to our answer over here. Okay, I hope that helped. That was the first sample problem. Um, there's be a second sample problem with a little different question being asked, but same idea. Okay, so thank you for joining me.